So let's look at how to find the area of trapezoids and rhombuses and kites. That's what we were just talking about, right? So, alright, so it says find the area of the quadrilateral. So first let's determine what type of quadrilateral it is. What we want to notice is that we have one pair of parallel sides, therefore it is a trapezoid. We went through the derivation of the area formula of a trapezoid. So let's just recall that the area of a trapezoid is height times the sum of the bases, and then we divide by 2. Okay, so if we look at what our information is that we already know, we know that base 1 is 14, we know base 2 is 37. What we do not know is the height. Okay, so we have to find the height in order to solve. So if I just draw on my altitude, which would be my height of the trapezoid. Remember, a height is an altitude. It's measured from the highest point perpendicular to that base. Okay? Now, look at what we just created here. We have this right triangle. But the only thing we know about this right triangle is that we have an angle of 42 degrees. But I actually do know something else. Because what I did by dropping this altitude, I created a rectangle here. And we know that the opposite sides of a rectangle are congruent. So we know that that side is going to be 14. And then if we subtract 37 minus 14, we get 23. So we do know a side of the right triangle. Now, what can we use to actually find the height? This is my height. Think a trig ratio, right? So we have the opposite, or we're looking for the opposite, given the adjacent, right? This is opposite adjacent. So we should be using the tangent ratio. So we're going to say the tangent of 42 is equal to h over 23. Okay, so if we solve that, we get 23 times the tangent of 42, and that's approximately 20.71. So I'm just going to substitute that in for my height in my formula. And now it's just calculator work. So 14 plus 37, and we're going to times that by 20.71, divide by 2, 1056.21 divided by 2, we get 528.105. And this would be units squared since we're talking area. Okay, so next problem, find the area of the quadrilateral. Let's determine what type of quadrilateral it is. We can see that we have two pairs of consecutive congruent sides. Therefore, this is a kite. Okay, so our kite formula, oh, hold on, sorry. Okay, so our kite, area of our kite formula, oh, are you kidding me? This was just working. Hold on. Alright, so now I think my pen's going to work here. Let's see. So, yes. No. Okay, there it is. Area of a kite is d1 times d2 over 2. So the length of diagonal 1 times the length of diagonal 2 divided by 2. Let's see what we have. Diagonal 1, diagonal 2, it doesn't matter which one you really call D1 or D2, you just need the lengths of both of them. And it looks like we don't have the length of a full diagonal at all. So we're going to have to do some working around that. Okay? Remember that the diagonals are perpendicular. So what we're creating here are these right triangles. So I could find, and remember also, besides the diagonals being perpendicular, this diagonal that joins the opposite congruent angles is actually bisected. So we know that those two pieces are congruent. Okay, that's going to be helpful. So what I'm going to do is I'm just going to look at this right triangle here, and we're going to have to find that missing side of my right triangle. So I'm going to, let me draw in that last piece. Okay, so there's the right triangle, where the leg is 16, the hypotenuse is 18, and we need to find that other leg. So we don't know any angle measures, which means that we just have to go to our handy-dandy Pythagorean theorem. So using the Pythagorean theorem, we get x squared is equal to 68, and then we need to square root 68. And I want to, let's use exact and see how messy this could be. So if the square root is 68, let's break that down. That's 2 and 34, 2 and 17. So it's 2 root 17. Okay, so that means that this piece of my diagonal is 2 root 17, which is actually the same as this one. So 2 root 17 plus 2 root 17 is how long? Yes, 4 root 17 when we add them together. Remember, when we add radicals, we add like radicals, just like having an x there. So 2x plus 2x is 4x. So 2 root 17 plus 2 root 17 is 4 root 17. Okay, so now that we know that that's 2 root 17, now let's try to help us find, let's find that other piece of the diagonal that's missing. Okay, so I drew that green right triangle, a little messy, so let me just draw it nicer here. I know that the hypotenuse is 11, and we're going to use our new value of 2 root 17 that we just found, and we need to find that little piece there. Okay, so again, we don't know any angle measures, so we're going to need to use the Pythagorean theorem. So 2 root 17 squared plus x squared equals 11 squared. And 2 root 17 squared is just, isn't it just 68? Yeah, it's 68 plus x squared equals 121. 121 minus 68 is 53, so x is the square root of 53. Oh yeah, this is an ugly one. So if we wanted to find the length of this diagonal, we would have to add the square root of 53 plus 16. Can't be done actually because that's a radical plus a whole number, so looks like we're going to go back to approximating. Okay, so if I'm going to approximate here, let's first approximate the square root 4 root 17, and that is about 16.5. And now if I do the square root of 53, square root of 53 is about 7.28, and we're going to add that to 16 for the length of the second diagonal. So let me do some, I'm sorry, this is a mess. Let me just erase this piece here. But we saw how we could use the Pythagorean theorem, right? Okay, so 4 root 17, that's 16.5, and we're going to multiply that by 23.28 and then divide by 2. Okay, so 16.5 times 23.28 and then divide by 2, and we get that the area is approximately 19.89 units squared. Okay, but I know I'm sorry I got messy there, but you still see the point that we're using our right triangle prior knowledge to help solve for these areas.